And welcome to episode 32 of Logicast, the AWS newscast brought to you by Logicata. I'm Karl Robinson, CEO and co-founder of Logicata, and I'm joined today by my colleague, John Goodall. How are you doing today, John?
You're trying very hard. I noticed you called
Still
it a newscast this time. That's new.
I thought I didn't have my teeth in properly and we were going down the nude podcast again, yeah.
Oh dear, this is no end of amusement. This is for new listeners. You're not going to get it, but the running joke is just incredibly funny at this point.
Well, normally John got a bit fed up of me introducing him, saying that he was on the podcast as always. So every week now I'm trying to think of an alternative to saying as always, and it usually just comes out as a pregnant pause. So anyway, I'm joined as always by my colleague, John Goodall. But also today we have a very special guest from the AWS Community Builder Program, Manoj Lingala. So Manoj, welcome to the podcast. Tell us a little bit about yourself.
Yeah, hey guys. I am Manoj. I'm working from Australia. So I've been a developer and hardcore backend developer from ages like over a decade ago. Recently, I've been promoted. Like I have been joined a lead engineer role for one of the big US superannuation company. So it's exciting. Yeah.
Excellent. And you have the dubious honour of being our first Australian guest, or Australia-based guest, Manoj. So yeah, we've been during our preamble, we were working out the time differences and the season differences. So John and I are just getting our day started. Your day is coming to a close. John and I are sat here in t-shirts and shorts, and we had a little bit of an audio issue with Manoj's fan heater because he's feeling a little bit cold in Australia. So yeah, we're definitely poles apart.
Yeah,
in terms of...
yeah, it's spring. It's spring in here, but it's because of night. It's a cold kicked in, so I have to, run the heater, obviously.
Yeah, well,
I'm pretty sure Australian spring is still pretty warm for a Brit.
Yeah.
That being said, I have some sort of Australian distant family and whatever. And whenever they come over here in summer, if we get a heat wave, they're just like, "Oh Jesus, I didn't know how hot this was," and they're really struggling. So it's a thing. It's a whole social media thing of people from properly hot countries, America, Australia, those kinds of places that don't have wet heat, that isn't humid, getting to the UK in a heat wave of 32 degrees and just go, they weren't kidding, this is horrible.
Yeah. During summers, it would be 30 plus or 40 plus sometimes in Australia. So we are get habituated to it as well. Yeah.
Well, interesting chat about the weather, guys. But as the regular listeners will know, we're not here to talk about the weather. We are here to talk about AWS news. Once a week, I collate a list of AWS news articles in my weekly AWS News Roundup newsletter. And then John and I pick a subset of those articles that we would love to talk about to you on the podcast. So we have, of course, got such a selections of articles this week, which we've all been reading over the weekend. And the first one is a new feature announcement on the AWS website about AWS Web Application Firewall. And specifically now the AWS WAF Bot Control now protects against distributed proxy-based attacks. So, John, what can you tell us about this one?
It's an interesting one. It's more MLification, I think, is what's going on. So it previously existed, so it's a new feature within a feature, if you like. The distributed proxy is the new bit. Targeted bots was just sophisticated bots that have ways of evading normal bot detection, and we've seen this. It's just kind of there. You just turn on the bot protection rule on WAF, and we've seen it on client accounts because you can see it in the graph. You can see bot control blocking, so you can see it doing its job. This, I think, is just making that a bit smarter so that if folk are using proxies such as, any proxy, there's stories of botnets using things like printers and connected speakers and all those sorts of things. So I think this is just a way of making that process a bit smarter to pick up on things that it hasn't already seen using ML, is what I think this is.
So MLification, is that a term you're going to use quite a lot? Because immediately it gave me a new idea for a parody song, just to add to my list of parody songs that I'd like to write.
Oh no. I don't think I've invented that term. I think MLification is a thing. Like ification is a thing of anything. There's some really quite rude ones as well, which I'm not going to repeat on here. But I don't think I've coined that.
Okay, but it reminded me of Californication, which is that Chili Peppers?
Yeah.
So yeah, let's add that to the list of parody songs that we'd like to write when we get the inspiration.
So long as there's no dancing elves.
So what about you, Manoj? Is this is AWS WAF in your world?
Yeah. Pretty obviously, like I'm a lead engineer, right? So I design a lot of microservices architecture oriented projects where obviously I came across this WAF rules which we played across. So basically the existing WAF rules which are targeting rules which are working perfectly fine. It has its own algorithms to identify what bot type is, what classification is, either it's a spam or web scraper or a fake social media bot. It's all been properly identified, and the target rules what we currently define would send a JavaScript to as a challenge to it would actually have to complete a captcha challenge to prove it's a human or a bot, right? So that's how the current functionality works, and it's how the request would allow or decline accordingly by the targets what we have defined. The main issue, as you guys were highlighting, are about the proxy servers. Now the intruders are becoming smart and smart, and they are using the proxy servers to hide the identity and and its IP addresses. So they actually how they are working is behind the scenes. They take control of a personal computer of a individual. So how they take a control, it's a different aspect of the discussion, but once they got the control of a system, then what they do is they transform the computer into a bot, and they switch them in a distributed way and attacks it. So what it happens is the target rules what we defined in the WAF section, which would avoid the IP addresses, identification of IP addresses, because it's been scattered geographically. So that's how they are bypassing the whatever the IP reputation rules and the rate limiting things coming to a specific IP address. That's how they are bypassing it. So it's good that AWS uh, did not notified what ML's languages algorithms they are using it, because again they might do a reverse engineering hack through that. So that's a good thing. And which because of AWS has a lot stack of log information. They know the trends, identifying what connections are allowed, what connections are rejected. So they have a good trends to identify and label accordingly. So this is a highest likelihood of a bot injection, or this is a medium, or this is a low one. So accordingly we can take an action on it. So it's pretty good approach of incorporating ML algorithms into it, and identifying the trends and likelihood of that bot behaviors. And one good thing is, again, it's a free of cost, so there is no additional cost which is incurred on it. So that's a good win for who are all using this feature. Yeah.
Absolutely. We're going to talk about cost later, as we often do on the podcast. But anything else you can do to protect yourself for free has got to be a win-win for all parties. And I know we're not really talking about chatbots here. We're talking about other types of bots. But I have found myself in situations where I've had to prove that I'm not a bot. When responding to queries on our website, etc. It's quite hard these days to figure out, whether you're talking to a human or not. And I do find myself occasionally having to prove that I am a human and not a bot.
So does that mean that you'd fail the Turing test?
I don't know. What is enlighten me, John, about the Turing test?
The Turing test is a thought experiment posited by Alan Turing, the famed computer scientist of World War II. And the idea is in a vacuum, so you can't see it, by asking an AI questions and listening to its responses, could it convince a human that it's a human?
Right. So I don't think I've failed it yet, but I've been worried at times that I might be failing it. So I'm desperately trying to convince a human via the power of typing text that I am actually another human. But maybe I wasn't even talking to a human. Who knows? Perhaps I was talking to a bot. There's an existential debate. But anyway, we're not here to talk about that, really, are we? So anyway,
let's don't want an existential crisis on the podcast.
No, I don't want to have an existential. I'm worried where this is going, so I think I need to move swiftly on to the next article. So the next article is all about. It's from the AWS community, actually, from Seth, Eliot, fellow member of the AWS community, and this one is entitled "Any Day Can Be Prime Day: How Amazon.com Search Uses Chaos Engineering to Handle Over 84,000 Requests per Second." So that's a big title, lots to unpack in this article. We've spoken a bit about chaos engineering on the podcast before. I don't think we've spoken about Prime Day, but every year Prime Day does spawn a whole series of blog posts, usually starting with our man, and his name is going to escape me now. So, Jeff Barr always writes a big blog post about how Amazon Web Services has kind of supported Prime Day, the resources consumed by Prime Day, etc. Our friend, my brain is just not working this morning. Costman does parody songs.
Corey Quinn.
Corey Quinn, of course. How could I forget Corey Quinn's name? Corey Quinn writes blog posts.
I should have to tag him because he's a community builder as well, and tell him you forgot.
So we're mentioning Corey Quinn on the podcast. Shameless mention of Corey Quinn, so we can tag him and maybe get some more listeners. But no, Corey Quinn usually writes a post about how much it might have cost to run Prime Day on AWS, etc. But Prime Day is absolutely huge. It's Amazon. I think it happens more than once a year now, but it's the big sale that happens on Amazon.com when you can buy stuff even cheaper than normal. Of course, they have a huge spike in traffic and search, as it mentions here, over 84,000 search requests per second, which for most of us is completely mind-boggling and not something we'll ever have to deal with. This article is all about how Amazon are using chaos engineering techniques to help ensure that the site stays live during those huge spikes of traffic. So, Manoj, I know you were keen to talk about this one because this dovetails very nicely into your world. So, what are your thoughts on this?
So that article mentions a lot of other aspects like DevOps and how they operate the things like two-piece team model. So what it actually captivates me, it's how they have detailed out Amazon, how they are orchestrating, how they are making use of the AWS fault injection simulator as a service. So those are the captivating things. I wanted to discuss that, how we can leverage it. So in this microservices world, when we design the application, so there will be many services which talks, and there is a eventual consistency approach what we follow for the development. So obviously there is a latencies between your read models and write models, right? So in order to make a system resilient enough to make it chaotic enough to understand chaotic in the sense in a good way, we are making it chaos, like testing it and ensuring it the production system is not breakable, or in case if it is breaks, what are the other approaches what we can follow, right? So in order to achieve that, traditionally we have to write so how I handled was like implementing a new services where I have to touch base the core, mimic the core functionalities, and disrupt the events, and make the system work on a load and see how it operates. It's a pretty complicated way of implementation, and there are different lot of tools and things which are required to make it happen. So the good thing is, like, with a AWS fault injector simulator, it's a managed service by AWS. So they are actually providing default templates where we can play around and do the experiments. Like, we can configure what are the AWS services which are required. So let's say for the discussion purpose, we want a EC2 or a containers or whatever, we can configure that. And on the load, how it happens, how it is taking up the load, and what are all the actions which we have to take, and are there any stop conditions which are required, and where this lock should go. So all these things can be defined in that experimented JSON file, and you can plug and play that and run that and see how it system is working on a load, and withstands the turbulence conditions in the production load. So that is one of the interesting thing which I felt to be discussed to the wider audiences, to introduce this kind of a not new feature. I think it came up in 2020 or 2021, but most of the people not aware of this injection simulator. Yeah.
I liked the concept of the and-on cord, the big red button. Stop! My chaos experiment is breaking my app. Stop now. Just press the big red button. I also like the, it explains something to me as well, this article, as to why sometimes Amazon search results appear a little bit different.
Yeah. So that's
display a kind of a minimum.
So that's a different it's a other design approach of the graceful degradation design approach. So if something happened on a load, how the systems continue to operate. If something, a component or a service failed, that failing can be a altogether different concept. Like it could be a rate limiting, or it could be circuit breaker issues with the downstream systems. That's a different topic. But if something happened on the integration point or a component, if that fails, what is a minimum reduced functionality which we can show gracefully? So that's what that design approach talks about. So that is one of the other feature of this chaotic engineering, or
graceful degradation. I like the sound of that. I like to think that's how I'm aging.
Yeah.
You're definitely degrading.
Yeah. Whether it's graceful or not, I don't know. But what about you, John? What are your thoughts on this one?
I mean, we've spoken about
this before.
Yeah, we've spoken about FIS before, but a little while ago now, when they were integrating a new feature or some such. It's definitely an interesting one. I mean, it does talk a lot about undifferentiated heavy lifting, which is the thing that AWS generally is keen of getting rid of for customers. But it feels like that there's a team that's built some tooling on top of the tooling that's then being used to reduce the lifting. But yeah, no, generally very interesting. And I didn't actually know that about search either. So that's cool. Good to know.
Yeah. Which part you didn't know?
The
graceful degradation part.
I knew that was a thing, but I didn't know that AWS did it. So yeah, or Amazon.com, I suppose, did it. But yeah, interesting. Very interesting.
And this coyote, this engineering is got famous by this, Netflix architecture when it came up, like Chaos Monkey testing it, the load on the servers like Chaotic Monkey. So that's what it term got fancier and got more popularity. So that's where people went.
They've got 3 animals now, I think. There's the monkey, the gorilla, and the snail, which is just brilliant.
Yeah.
Oh yes, I do remember us talking about all of these various
chaos animals.
Yeah.
Fauna on a previous episode. I've been thinking about doing my own chaos engineering experiment, actually, because my stepdaughter has asked if she can have an 18th birthday house party in the house. So I need to be a chaos monkey going around seeing what things people can break in my house before the party takes place. I know it's not quite the same, but maybe I could write an app for it. Cool. So let's move on from chaos engineering and talk a little bit about, I don't know if this is a sad day or if it's just progress, really, but recently you may have seen in the news, it's got a lot of coverage, but AWS has shut down its first generation compute and network infrastructure known as EC2 Classic. So really one of the very early services. I think S3 was the first service. Oh, no, it wasn't.
SQS.
It was SQS. But S3 came before EC2, I believe. But the first generation of the Elastic Compute Cloud has recently been shut down after 16 years of loyal service. So, yeah, do you want to read the obituary, John?
I mean, it's a bit long for an obituary. It's not going to say, I was born here and lived there and married so-and-so. It's an interesting one. I didn't think we couldn't not talk about this one because it's such a high-profile kind of item. EC2 Classic, it was one of the first services, and it's almost certainly the first IaaS service just anywhere. So it's incredibly key, very pivotal. But it wasn't the VPCs and logically isolated networks that we know today. You were on a flat bit of hardware shared with everybody else. Yeah, okay, you had security groups so you could control traffic in and out, but you were not completely isolated. It's very interesting the way they've done this. Interesting is probably the wrong word. This is very much on brand for AWS, where they announced that they were going to do it 2 years ago, and that was 7 years after they'd deprecated it properly with VPCs for everybody. So it'd been deprecated for a very long time, and you had to really work hard to spin up new EC2 Classics. And I think post 2013 or 14, you couldn't at all anyway. So it was only pre-existing folk that were still on the kit. And they announced it 2 years ago, and it's finally done. One of the things that the article does touch on that our friend Jeff was quite proud of was it Jeff? Was it Werner? Werner? One of the two of them was basically saying that they didn't force anyone out. Like everybody was off before it got shut down. Right? There was no last minute get out the door type run that you can see with things like services being shut down and data centers being migrated and all the rest of it. There's this mad dash to the finish, and this doesn't appear to have happened. It was, we are going to shut it down. Everybody leave. Here's how you do it. We'll support you, and we'll hold your hand all the way, and all the rest of it. And they very much seem to have done that. And now everybody's out, and they've turned it off. And long may those servers rest, because they probably worked very hard.
Yeah. Make space for the next generation of AI chips to be wheeled in. But any thoughts on this one, Manoj?
Not much opinionated one on this, but I say it's good that it's been shut down. It's a yeah.
You didn't have to move any instances off yourself?
No, because it's all microservices. Is the business's targets on the serverless architecture. So
Yeah.
there is less people they use EC2s in like in my experiences, only for the VMs for the dev purposes, because people don't
Yeah.
want to get into the complexity overheads of operationals and network and whatever complexity comes with the storage volumes as well. On and off it goes and comes up. So yeah, it's a bit chaotic for me. Yeah, with EC2s. Yeah.
Yeah, it's nice that you are able to work in that cloud native paradigm.
Yeah.
Don't get me wrong. I'm a full serverless fanboy, right? Within the community builder program, I'm in the serverless category, but I think everybody probably got their start on servers, so I'm just a little bit nostalgic for them, which is a weird thing to be nostalgic for, but like, okay. Yeah.
They're still there, though. They're still there, those servers. You just don't have to do anything with them.
Well, yeah, quite.
Yeah. Okay, well, let's move on then. The last couple of articles that we've selected this week are all around cost. So the first one's an article on Information Age, key ways to save on AWS costs. So a lot of this is just kind of repeating things that we already know, but there's a huge amount of noise about this in the press at the moment because it has been identified as a major priority for many organizations. Even this morning we were talking about one of our own managed services customers who's getting a lot of pressure from their investors to reduce cost. So it's definitely an important discussion area. So John, was there anything in particular that jumped out from this article in terms of ways to reduce AWS costs?
I mean, there's nothing specific on this article, and I know I've kind of picked two, but one of them is a slightly different slant. But I think it's always worth every so often just revisiting this topic because, as you say, it's in the press quite a bit, and whilst we as professionals kind of know all these things, we have to assume that people don't. So it's worth definitely revisiting this topic every couple of months or so. I mean, I'm just going to list them top down. Realistically, the key one is monitoring. You can't save money on what you can't see and you can't identify. You need to know what you're running. You need to know whether they're provisioned adequately or not, whether you're spending more money than you should, or whether you're operating at risk because your servers are too small, because you wanted to save some money and it wasn't necessarily the right place to do it because it's costing you revenue. So monitoring is the key one. Once you've got more monitoring in place, once you've got enough monitoring in place, elasticity is another cool one. So we talk about EC2, certainly in the previous one. The E stands for elastic. What that basically means in this context is you can flex your resources up and down to meet demand. You don't have to do that automatically, but you certainly can. Things like auto scaling grips and what have you. That makes your life a whole hell of a lot easier because you kind of don't worry about it. You just set your tracking policies or your scaling policies to say, is it sitting at X% CPU, or are there Y number of requests queuing up at the load balancer or whatever? And then you can scale in and out to meet demand and save costs when those numbers drop. Data storage, again, useful because whilst no one storage method is appropriate for every workload, and all of them are relatively cheap, like the most expensive I think is about 10 cents a gigabyte, which is not horrifically expensive, but when you get into terabyte and petabyte scales, those numbers can add up. So it's just a case of making sure that your data is where it's sensible to be, particularly for S3 based data and workloads that can work with S3. Just use intelligent tiering. Yeah, okay, you could save a little bit more money by using Glacier and Deep Archive, but your engineering cost to get that to work is probably going to be higher than the amount of money you're going to save by not using intelligent tiering. So just use intelligent tiering. And then it talks about measuring and monitoring, which is a key part of DevOps generally. Measuring, monitoring, and consistent improvement, something that we kind of preach generally, given any opportunity, is consistent improvement. So it's all fun and good doing all these things and knowing about everything, but if you're not making strides to actually make your life better, what are you doing? And then there's a couple of bits in there as well. Again, we preach these as well. Spot instances are great, but only if your workload support them. Savings plans and volume discounts, again, yeah, love them. And then moving to Glacier, it talks about storage again. Yeah, Glacier is incredibly cheap. It's like $1 for a terabyte for a month, which is just nothing. But you do have to know how to use it because there's like a 12-hour wait time to get your data. Yeah, that's kind of it, really. The key thing for me, as it says at the bottom of the article, is a comprehensive approach. You can't just look at one thing in isolation. You can't just say, oh, I can use a savings plan. But you could have saved more money by turning off your dev servers, or I'm going to turn off my production servers. But then you're not running prod and you're not making money. So maybe a savings plan would be better in that scenario, and so on. It's looking at things holistically that's important for me.
So what I wanted to ask Manoj is that a lot of these measures are all kind of on the infrastructure side of things.
Yeah.
But given that you're more from a software development background, Manoj, I mean, what sort of pressures are there on developers these days to write more cost-efficient code? I mean, is that a thing in your world, or is it really still more down to the infrastructure guys to run it as, in as optimized a fashion as they can? Or is it relevant in your day-to-day to trying to ensure that you're writing cost-efficient code?
Yeah, pretty much. Like we use EKS and ECRs a lot, and we ensure the size of that image is pretty less, and that is one of the aspect of our cost savings, and also the automated policies of S3. When we have a large storage, and how the transformation happens from the frequent access data to a less frequent access data. So there are a bit of automated policies which we can spin up through info and make it automated for that. And the important thing mostly people ignore is I have written an article a couple of months ago on the optimizing DynamoDB cost. So usually it's pretty cheap, but when you don't create the keys properly, for say when you create a GSI keys for the better searching capabilities, so usually developers tends to create with all projections. So whatever the fields which are present in that Dynamo, so projecting that everything, so which adds a lot of cost to it unknowingly. So there I've written an article to how smartly we can create a GSIs, and what are the projection types which we have to use explicitly. So there are include projection type which can be used to only include the keys which are needed for the projections to be queried at later point of time. So these are the tiny bits where developers have to be cautious for the cost of optimizations part. Yeah.
Cool. I'm conscious of time.
Okay.
We've seem to be reaching the end of our time very quickly, and we've got a fifth article that we haven't touched on. So, John, was there anything specific that you wanted to pull out of this one that we haven't already covered?
I mean, it's a bit of a rehash of the previous one, but from a FinOps kind of slant. So the only other things it talks about is budgeting and forecasting, which is not necessarily helping you save money, but more understanding where your money's going. So you set your budgets and you know when you hit your budgets and you know what the services are and so on. And then cloud governance, which is not so much, we don't see it so much in the SMB sort of space. It's much more in the, X hundreds of thousands of dollars a month spend type companies. They're in that kind of area where they need to set up things like centers of excellence and cost saving centers of excellence and dealing with governance so that you can say only people that have access to certain things can spin up certain things, and making sure that developers can't spin up large instances or make reservations of like a 3-year Elasticache reservation, because then because you've end up spending hundreds of thousands of dollars on something that you needed not really because someone pushed the wrong button. So there's definitely things that can be learnt from the second article as well, but like I say, it's just a different slant on the same topic.
Yeah, it's mostly overlapping a few of the things there.
Yeah, a good bit of reinforcement never hurts. So I think there's a statistic that you have to be told something 12 times before you actually take it in, I think. So, we've repeated it a couple more times here. So hopefully it's going to help sink in for the listeners. But as I mentioned, we have come to the end of our time this week for season 2, episode 32 of Logicast. So thank you, as always, John, for your insights. And thank you to our very special guest, Manoj Lingala. We really appreciated your insights today as well. So thank you for listening.
Thank you.
Please do like and subscribe to the podcast for new episodes every week. And of course, we will be sharing the links to the articles in the show notes if you'd like to read those articles for yourself. And we'll also be sharing Manoj's social details in the show notes if you'd like to follow Manoj's updates as he progresses through the AWS Community Builder program. So thank you for listening. We'll see you again next week. Cheers.
Cheers.